Hello, my name is Isabella and I will be your host for another mathematics video brought to you by RJ. A few years ago, the game Wordle took the world by storm, but now the game craze is connections. In this game, you are given 16 words and you must make 4 groups of 4 words based on something the 4 words have in common. This brings me to my question for today. How many possible solutions of connections are there? First, we choose 4 words out of 16, so we have 16 choose 4. But we would be overcounting, so we need to divide by how many groups of 4 are possible, which is 4 choose 1. Then we choose 4 words out of the remaining 12, so we have 12 choose 4. Again, we would be overcounting, so we need to divide by how many groups of 4 are possible, which is 3 choose 1. After that, we choose 4 words out of the remaining 8, so we have 8 choose 4. Once more, we would be overcounting, so we need to divide by how many groups of 4 are possible, which would be 2 choose 1. Finally, we choose 4 words out of the remaining 4, so we have 4 choose 4. We still have to account for overcounting, so we need to divide by how many groups of 4 are possible, which is 1 choose 1. We can calculate each of the terms to these numbers, which, when multiplied out, equals this number. This is how many possible solutions there are to connections. But wait, is there a general formula for this? Note that connections use 4 groups of 4 words, which is a square. So let's consider any square of n. Recall that this is the formula for the binomial coefficient. Notice that the denominators are just 4 factorial or n factorial in our new case. Also notice that these are the product of binomial coefficients of multiples of 4 or n. Therefore, we can construct a general formula. But let's use this formula to break it up. It looks like we made it way more complicated, but actually when we express it this way, we can simplify it piece by piece. This is just n factorial multiplied by itself n times. We can also rewrite this as, look, every term in the bottom product cancels out with a term in the top product, except for the very last one, which is n squared factorial. Now, I did not have enough space to complete this, but in this equation, we would just put the equal sign here and continue it outwards. But regardless, we now have a simplified general formula for how many possible solutions there are for a square connections game. If we plug in 4 for n, we get to see that we get this number. If we plug in 1 for n, we get 1, and that would be a boring game. If we plug in 2 for n, we get 3. If we plug in 3 for n, we get 280. Since connections is a daily game, it would make sense that n equals 4, since this is the smallest number that the same solution wouldn't show up again in under a year. In fact, when n equals 4, the same solution won't appear again for over 7,000 years. I leave you with one question. We assume that the game was a square. How would this formula be different if it wasn't a square? I hope you enjoyed the video. If you did and would like to see future videos, please like and subscribe. Also, if you are looking for math tutoring, whether it be algebra, geometry, or calculus, please contact RJ through one of his social media profiles, Eternal Love Onk. Thank you for watching.